All right, I guess we'll get going. Thank you, Robert and Selena. I just sent you a link for Repellent. I'll also send you a link to the problem we're about to try to solve, which is merge two sorted lists. So we'll be using the linked list, which is probably new to both of you. So we'll see what challenges that arises to when we get to them. We'll be going through the UMPIRE method. Share my screen. All right. So this is the leak code. Did I post that in there? Pull up my chat. Yeah, okay. So the leak code link, that is the actual question. You may or may not have a leak code account. If you don't, it's not a big deal. The only one you really need or could use, but you can also, I think, do anonymous, is the Repellent. But I'm going to copy this off, which is the problem. I'm going to go over to my Repellents. Just going to add some comments on to the top here. All right, so this is our problem. We're going to merge two sorted linked lists and return it as a new sorted list. The new list should be made by splicing together the nodes of the first two lists. And those first two lists are 1, 2, 4 and 1, 3, 4. We don't have those the main constructed yet, but we will do that after we get to the main piece. So as a result, we're going to end up with, again, this will be a sorted list when we combine them together with 1, 1, 2, 3, 4, 4. In combining the lists, we're not removing any duplicates. We're simply merging those two lists together. There are other problems where we can remove the duplicates, or we can do them as a additional piece on this particular exercise and just add a new method to delete any duplicates. All right. So we are going to have, let me make sure we get this right. We're going to return the list node, which is built right here. So I'm going to copy this because we're going to need this portion. This is our constructor for our linked list for the nodes. Oop. Doing some funky stuff tonight, I see. Get out all the asterisks that are just going to cause problems. Give me 1 second. Okay, so we're going to import the constructor class for our list node. So when building the linked list, we need to create a constructor for the particular nodes. So in this constructor, we have a next. We have a callback to the list node, and then we also have the ability to view its value, and that's either through this.val or this.next. And that I'll change it to the next one in the list. All right. And then I'm going to go make sure we grab the correct call or method. Okay. So this is going to be our method, and our method has two significant parts that we need to understand here. We're going to return a list node, so we're going to have to create a new node in order for us to have a linked list, or so we're going to have to create a new linked list so that we can present the results. It's possible to do it by just adding it to one of the two lists, but that gets a little too complex to what we're trying to do today. So we're just going to create a third list, and we're going to input, in this case, we're going to input two linked lists, essentially L1 and L2, and those two lists, which are respectively 124 and 134, will then create the ensuing list node that the linked list that we're about to build. Sorry, I know it's kind of confusing as I keep going from linked list to list node. I'll just try to stick with list node, but just to understand that list node is a linked list. So we're going to create, or we're going to call to the constructor class, the list node, and create a new list so that we have something to return. So in this case, we're just going to return call list node, just like if we were using like the scanner class, or what else would you guys, using calling other classes. In this case, we're just calling the list node constructor. And this constructor is part of the overall main class. All right, so we're going to call this result, just so that we remember that this is what we're going to output out to the main, return to the main. So we're going to then create a new list node, and we're going to fill it with 0. So this is going to be our first, basically we're creating the first node by doing this, and it's going to be called result. All right. Okay. Can you repost the Repellent, Selena? That way he can have it and he can come back and look at the finished project too. I don't know if the chat gets recorded in the YouTube or not. All right. So now we're going to then, okay. Now we're going to create our instance, another instance based on our first instance. So we're going to do another list node. I'm going to call this one P, and then we're going to refer back to the first instance, which is result. And what that P will do is it's going to be where we, this is going to be the full list, and result is going to be the first node. And actually, so let's look through this. We're going to change this. I'm going to change it from result to head. So we just remember this is going to be the head node, first one. Okay. but our list is going to end up being called P in this case. So I'm going to change that P then to result. All right. So what we're going to do now is we're going to create basically two more pieces. And what we're going to do is we're going to fill these temps in from our inputs. So our first one will be list node. We'll just call it P1, and this will equal to L1. List node 2 equal to L2. All right. So when we look at the nodes themselves, what this is going to just basically take our nodes that are coming in, so they're full list, and we're going to then be able to have a working copy of this, so we won't have any issues if we mess up or anything like that. Okay. All right. So basically, we've done all of the back work that we have to do here to get started. So what we're going to do now is we're going to start iterating through what is now going to be our P1s and P2s, so that we can then capture the values that we're going to do, and then be able to take the ones that we need to take in order to then put into our new linked list, i.e. merging them together. So we're going to use a while, and we're going to have two conditions in this while statement, or in this while loop. So our first one's just going to be P1, and while P1 is not equal to null, okay, so P1 is really going to be the first node value. So as long as there's a value in that node, we are happy and we can continue. If it's null, then we're going to stop our loop. And we're also going to do our corresponding condition in here is going to be doing the same thing for the second list. And why we want to do it for the second list is we want to make sure that, that we're not trying to add additional nodes that don't exist. So the two linked lists should be sorted, and they should be of the same length. So that was not addressed there. All right, so we'll open up our while loop, and inside our while loop, we're going to start with an if statement. And what we have to determine is which value is going to be the first one that we're going to put into our new linked list, because we want to make sure that's sorted. So in this case, we have 2 1s, so it's not necessarily going to matter which one we put in first. But you can imagine if, for example, let's just copy this over and make it a little easier. So let's say we have like a 0, okay, a 0 and a 2. Where'd my 0 go? It's weird here. All right, so a 0 or a 2, and let's say we have a 5. So we have a 0, a 2, or 5. So what I'm expecting to see is that we would get a 0, 2 2s, a 4, and then a 5 to stay in that sorted means. So we want to make sure that we're taking these two when we're putting together, that we're sorting each node against each other so that we can stay in order. So we're going to start with P1. All right, and alluded to this a little bit. To get the value, we're going to use the value from list node up here. So to do that, we're going to do p1.val. So what that's going to do is it's going to look in the node and it's going to look at the value that's in that particular node. Much like we do with an array, you can think of each node as an index, and then we're going to look inside that index for the value. In this case, we're just using val for it, the .val. So if val1 is less than p2 val, then we're going to do something. Okay. So we're going to, in this case, we're going to go and we're going to look at results dot next. So that's another one coming from our constructor. In this case, it's the next piece up here and connecting the same way dot next. So we're going to look at the next iteration of what's already in the result list. As we go through our first time, our first node, if you remember, we created head up in line 26. So we do have a value at 0. So if they equal to each other, then what we're going to do is we're going to stick and we're going to replace that value of that next node with the value of P1. Or really not even P1, we're just going to replace the two nodes themselves. And we're also going to make P1 then equal something else, which we're going to basically iterate it up to the next one. So because this is a while loop, and usually you'll build yourself a counter to get through the entire array or whatever it is that you're looking through. That's how we're going to navigate through the while loop, is by doing these nexts. All right, and then, so our else is going to be very much the same as we had here. So I'm just going to copy them over. And instead of P1, it'll be P2. So if the P1 is less, then P1 will go into our first node. And if P2 is less, then that will go in as our first node. And then it'll iterate through to the next one. And then what we're going to do is we're going to finish off this while loop with iterating through the new linked list of results. So result will then equal result dot next, and that'll move us to the next result, and so on. All right. So if we don't have a main to run this on yet. So we have basically now constructed our while loop to cycle through these two lists. And as we cycle through these two lists, we will fill up our new result piece. All right. So we're going to do two additional things here because we may end up having a null case in our while. So if, for example, our lists are 3 nodes and then 4 nodes, we're only going to be able to put 3 nodes through on each. We're not going to get to that 4th. So we have to have we have to cover those edge cases to ensure that we can get we get any additional nodes in to our list. We can do that quite easily. We're just going to do two different if statements. So we're going to do an if. So if P1 in this case is not equal to null, what we're going to do is we're going to go and we're going to put then result dot next will equal then the P1. So we'll just keep going through and put in that extra those extra nodes into our result linked list if we have an additional P1 node. We'll do the same thing with P2. Get my shifts correct. So this one will be result next equals P2. All right. Then the only thing we have left now is we are going to then return our lists coming through. So we're just going to do that with simply returning the next head. So that we're just going to basically cycle through and return the list that way. We're going to return head next. Right. So this is basically our code. What I'm going to do is I'm going to take this, because I don't really want to make a main. I'm going to go back to the leak code. I think I captured that. So I'm going to paste that in there. I'm going to run the code. Oh, so our time was exceeded. All right, so we took too much time to complete this with this particular method. So it's never good. Oh, it just gives me, doesn't give me anything. All right, so we need to figure out why we went so far off. P results through. So we have head, list 0. We have the results coming from head. We have the list nodes for P1, P2, 1 and 2 are not equal or not nulls, and P's not nulls. And if the value for 1 is less than the value for 2, then we're going to stick 1 into results, and we'll cycle to the next in P1. Right? Yep. Then we're going to go to else. We'll do the exact same thing. And then we make sure we cycle to the next results. What we'll do is, let's type this instead. See if we just return the list. Time exceeded still. What kind of list are they trying to push to us? Of course, none of you guys have worked on linked lists yet, have you? Like, why am I going out of my mind here? And if P, that's not null. That's not null. I'm gonna go through. Eventually, those get nulls. So. One, two, two, three. Okay. So we're not outputting exactly right. Okay. Let's go back to say that was head.next. Okay. So we did not, we're missing one. Okay. So we're not catching the last piece. We're not getting the last node. So go one, go two, then if P2 does not null, then P2 goes in. Should have caught it there. I'm just going to change these to time exceeded. Too much on a while loop, apparently. So we have to figure out how to get that last one in. I think what we're getting here is that. So, because we get the 2, so if we were to say this should, oh, that will not. So let's see, 3, 2, 4, that should run for us. Okay, and again, we're not getting the last one in. All right, so we're not getting the last one, so we have to, we're getting that. This next somewhere. Ah, right here, right there. Typo. P2 All right. So I missed when I copied and pasted, which is apparently not always good. I missed changing on line 25. I still had P1. So when I changed it from P1 to P2, then everything worked out well. So what I was trying to do was always taking from the first list, and it only took, so it had no clue what I was asking it to do. So let's change our test case back to 124 and 134. Run this out. And we have got a winner. We get the right output, everything else. All right. So that's our first problem. You guys have any questions on it? I'll go with Selena's answer, final answer. All right. So if you want, you can stick this in your leak code if you have a leak code, and then just submit it. I'm going to submit it so I get some time. See how we do. Oh, so we're 100% faster. All right. Which is funny since I was running out of time before, and my memory usage is in. So, okay. So that's the first problem I wanted to go over tonight. That's just merging two lists. We're just going and using linked lists. So what I want to kind of talk about too is stacks and queues. Are you guys familiar with stacks? Are you familiar with queues? When I say that, do you understand what I'm saying? We need to just talk about it a little bit since I didn't really talk about linked lists.
You can talk a little bit about the stack. I'm not too familiar with it.
Okay.
Leonard.
No problem. All right. So we get a nice color. I'll do a nice green. Okay. So a stack is what we call, it's first in, last out. So philo. First in, last out. All right. So what the stack essentially is, if you think about it, is just think about those little ring toys that your kids had or you had when you were a kid. You know, you put the big ring in, put the next ring in, and you either size it up or you don't size it up or whatever. All right. So let's say we have 4 rings. No matter what we do, when we stack those 4 rings up on the post, we can never get that first one off first. We always have to take the last one off that we took off, put on the post, then the next one, then the next one, and then finally we get down to the first one we put on the post. So that is what we call the first in, last out concept. So if we have a, let's say we have 2, 5, 6, and 3 are our numbers, and we're going to stick them, into our stack. It'll correspond to 2, 5, 6, and 3. And the method that we use to put these into the stack is push. So we end up essentially pushing that first 2 into the stack. And then to get them off the stack, we pop them. So what the construction would look like is essentially the name of your stack. So if we construct our stack, then we have, put that in small, in lowercase stack equals new stack. And I forgot, we need angle brackets here because in the stack we need to tell what type it is. So you can put a temp p in there, but you need to tell a stack whether it's doing integers, strings, doubles, whatever it is. It has to the type has to go within 2 angle brackets right there. So for example, we would, and it's always the class type. So in this case, double with a capital D. So in that stack, we would be putting, it would be a stack of doubles. Oops. And occasionally we also have to put it at the end of the stack here before the parentheses on our call, right? And so using the lowercase stand, our calls would be, our stack, would be stack dot push, or stack dot pop. So the pop is always going to be, the parentheses are always going to be empty because there's no parameters we need in order to pop that off. But typically we're going to have the value within the push, within those parentheses. So you'll have some value, and in this case it'll be a double, so we can say like 0.0 would be the value that we would push onto our stack. So in this case, our stack, if they were doubles, would look something like this, the point zeros. We also have another method that we can use in here, which is called peak. And what the peak does is just called stack, calling it with the variable for that class. So stack peak, and this also does not need a parameter, but what it'll do is it will peek at the first or the top of our stack and return the value for the top of the stack. It doesn't remove it, and it doesn't push anything onto it. It just looks and sees what that value is right here. Okay. So I'm just going to, so these are the basic functions here. And then the empty is, true or false. Is there anything in the stack itself? So in this case, it would just be there's already a built-in method into this class, and much like the push, the pop, it's just a dot is empty. And then you would just start with the name of the stack. So in this case, stack with a lower s. So with that, those are basically our commands to work the stack. All right. Now, of course, conversely, our other piece is the queue. If I can get over to the queue. I'll let you guys, if you need to take a screenshot, take one now. So I'm about to erase the stack stuff. queue, pop, push, push. Interesting. All right. And the stack. I'm going to queue using stacks. I'm going to stack using queues. All right. So we're going to basically do this, be doing the same thing, except for, so we'll be using the push method over here and the pop, and then the top, which is your peak, and then finding the empty. All right. So what our queue pieces are, which is, I'm not sure why we're not looking for our queues. Typically we're getting so our queue is well, our stack was first in, last out. So this one, our queue is first in, first out. So if you think about a queue, I mean, a queue is just a line. You know, when you're lining up at Six Flags or something, you know, you get stuck in a queue, or maybe you're stuck in a queue at HEB, waiting for the cashier, whatever it is. The first person there, right, gets served first, and then everyone behind has to wait until the first one leaves. So the first one that we place in our list or in our queue is always going to be the first one that we're going to get out. So it's, you know, basically, I want to say exactly the opposite of doing the stack, but it's semi-opposite. How's that? Halfway opposite. Versus, you know, in the effect that we're going to basically think of it as the same construction, if you will, of the stack or an array. When the stack was vertical, this one's horizontal, just like an array is. So we would put in our 2, our 5, a 3, a 6, and a 9, for example. And we would, when we pop, the first one comes out. And depending on how we do that, we're typically going to lose that first index of our queue. So just in like a stack and in the queue, you can think of it, you have a value here in our little memory hole. You have a value, so that's going to be your, in this case, those integers. And then there's also some memory space to link it to the next part. Because in your memory, value, and then you link back to the next one and so forth. All right. Because in your memory, of course, everything's not going to go straight in line. So the queue and the stack and all of the data structures, they all have kind of a little extra space to know where the next piece in the iteration is in the memory, on your hard drive or on your disk or thumb drive, wherever it is that is being saved. And so what'll happen is when we pop that first one, we pop this, and then this goes away. And what happens is this link goes away too. So now, if this one was the head of the queue before, once this is dead, then this one now becomes the head. and all that link and everything else is gone. So that's kind of how the queue works. So just because, you know, you don't, I mean, it's when you're standing in line at HEB now, they have those little stickers on the floor, you know, the 6 feet distance ones. But you're not, you may be occupying that sticker in the queue, but you're not occupying the same body as the person before you was. All right. So that's, so we have the same thing. The top will be our peak. The push will be the push. The pop is the pop. So, and then we're going to also have the empty, which is just is empty. So, all right. So what we're going to do now is we're going to go back over to our implementation of our queue using stacks. All right. So we have a little bit of a difference here because we have a two different data structures that work kind of similarly, but not quite so, because when we're trying to implement the queue using stacks, we have to take the first in, last out approach and modify that now to be the first in, first out. So how do we do that? Well, we can't do it with just one stack, but we can do it with multiple stacks. So if, for example, we have two stacks, and then I'll draw this down here to represent our queue. So we'll say we have 4. So we'll just say 1, 2, 3, 4. Okay. So our first in was our 1, our second 2, then our 3, and then our 4. So in our first stack, that is how we would end up doing that. So we would end up having to put in our first number, which is 1, our second, our third, and our fourth. And now we cannot effectively get to 1 to replicate the queue, where when we pop from the queue, we expect to pop 1. If we pop from here, we're going to get 4. So how do we get 1? What we're going to effectively have to do is we're going to have to pop. So we'll pop 4, and 4 will come here. We'll pop 3, and 3 will come here. And then we'll pop 2, and 2 will come here. Now, as we pop 1 here, and we've done those 3 previous commands in this stack, we can now pop the 4th, and we can get 1. So this is 1 pop, and this is essentially 4 pops. Think about it, okay? Or basically as many pops as I need based on the length of or the height of the stack. But we can calculate that too, because we can hopefully determine the height of the stack based on the size method. So to pop, we have to do this 4 times. The other thing that we have to worry about is the peak. All right. So to peak, we would, let's say we've already popped 1. Okay, so this is gone. This is gone. All right, I'm going to erase these. Oop, that's not the eraser. That's still not the eraser. No. So we start 3, 4. Let me see if I can erase these out. No, I'm the toughest time with just the eraser. All right. So we start with a 2, 3, 4. I want to peak at 2. I can do that with 1 command here, but I have to, again, pop these off so that I can then peak at what should be my first 1 in my queue. All right. Now, I didn't kind of mention this before. We pop these off. Oh, I'm sorry, that's not right. So we pop these off. We don't leave them over here. We have to pop them back over to the other side. Oh, no, I was right. I'm totally confused in what I did. Don't bother with me because I was wrong. This goes to here, and then this goes to here. So we're gonna pop these off. We'll do our peak, and then once we finish our peak, we have to pop these and push them back over here and put them back on to our original stack. We can't leave them over there. Otherwise, we risk having other issues when we're trying to do further commands. Okay? So I'm just going to clear this off. So we're going to that's the mouse. Let's see, this is. I'm just going to create a new one here. Java. Call this by the class myQ. And I go back over to this. I'm going to grab this information and back over here. Let me share that into the chat. So there's a new repellent for you to follow along with. And then I'm going to grab the directions. We have our directions. All right, so we pretty much should have a rough understanding of what we're trying to do here. All right, so we have our first, we have a couple of pieces that we have to push in here, but we're going to have to start off with with doing some stacks. Because we need the 2 stacks for us to be able to effectively move back and forth. So I'm just going to let me do this before. It's kind of lazy. So we're going to do stacks right here. And then our queue, so this is where we're going to basically build our information here. So public queue. I think, actually, I don't think we're going to need anything right now. So all our stuff's going to go in here. We might have to push. So maybe this is where we're going to do our calls, our 2 stacks as we initialize. Then we're going to push. So to push, we're going to have to make sure. Oops. So pushing is, we're going to make sure that want this value. I think we want to make sure that this I think we're going to do if sure stack is empty. I think we need it to be empty to be able to do our stuff. And if it is empty, we're going to do a push. X, which is our variable, onto stack. Not empty. We're going to if it's not empty, then we're going to take the stuff from the other stack. So let's say stack 1, stack 1. So stack 1 not empty. And we're going to have to, if stack 2 not empty, then we can push the stuff from stack 2 to stack 1. So what we'll end up doing in this part is, if this is going to be our test, so everything should be already pushed into our stack. So if our stack is empty, we need to make sure our first stack is empty. We want to make sure that the stuff is not over in the values in the other stack, in stack 2. So all those values would come and be pushed into the first stack. Right. And so what we'll do is, and then if it's not, we're going to push to second stack. That'll be our variable. So if it's empty, we push it into stack 1. If stack 1 is not empty, then we're going to push it into stack number 2. And why we want to do that is, so as we're inserting our new piece in, if you remember, we need to have that that value be the first element in our stack. So at the very bottom for everything to work. Conversely, it'll be the first element in our queue, which is where we want to take it off of first. So our first stack will be our queue vertically facing down, and then we'll pop everything from that first stack into the second stack as we pop and push from, like, doing our queue operations, basically, using the first stack as our base, if that makes sense. All right, and then so we do that, and then so we push the value on the X. So then if it's not empty, then we're going, if stack 2 is not empty, then we're going to push everything from stack 2 to stack 1. So that'll be, so we'll go to and from, back and forth. All right. So then our pop in front of the queue. So at this point, push, we should be able to just pop stack 1, so pop, I think that'll do it. And then we're gonna do the peak. We should be able to peak. These should just put, these are returns, because we're returning the index or the integer. Versus the push, which is a void. And the empty should be easy because we're just going to end up returning whether stack 1 is empty. Empty. All right, so So what we need to do now is we're gonna sorry, that's the data structure. So that's not it. Those aren't going to go there. I think we're going to have to build that out. All right, so we're going to call our two stacks. So we're just going to go nice and easy here. There we go, stack. It's going to be an integer, capital I, to call the integer class. And we're going to call this first one, we'll call this one the temp. This is going to be our temporary stack. So this is where we'll push everything to and fro. So stack, we have to make sure we get the integer back in here. Close it out with the parentheses and our semicolon. So we have one stack. Stack. Stack integer. Let's come back and instantiate that. Before we're just going to go through, before we create our constructor, we're just going to go through into our pieces here. So we're going to first make sure that our stack number one is empty. So that's going to be our values, our queue. So if our queue dot is empty, then we're going to do something, and that's something. So something that we do is we're going to push. So that's going to be Q. I'm going to push, and that's going to be X. And then if, so that's going to be our else statement here. So else, no, we're over here. So if, I think this is more of a, it's not so much an if, but while. It's just like our last exercise, we want to ensure that we have, we go through the entire list. In this case, we're going to go through the entire stack to make sure that whether it's empty or not. So if Q is empty, so I have, so since this is a conjoined method, the not, in this case, the exclamation point is going to go before the class call, which is the stack here, which is Q. So we have that. And so we're only going to do one thing here. And we're just going to take that push. So we're going to go and we're going to go from our temp. We're going to push. What we're going to push is our Q pop. So what we're ending up doing here is if the first queue is empty, or the first stack is empty, which we named Q, we're just going to push right on there. If not, we're going to pull everything out of that first stack and push it into the temporary stack. And once we pushed everything to that temporary stack, then what we're going to do is we're going to then take and we're going to push the value x, which is being passed in here, into the Q stack. Okay. And now, of course, we have to worry about putting everything back. So we're going to then go and put everything back. So we'll do another while loop. And in this case, we're going to do if the temp stack is not empty. If the temp stack is not empty in this case, we're going to take everything that's in the temp stack and we're going to stick it back into our Q stack. So just as we did before, taking everything from the Q and popping it into the push. So we're going to do Q push and temp pop. So we're pushing the value of the popping, the pop from the temp stack into the Q stack. All right. So then we're going to come down. We're just going to return. We're going to return. This is pop. We're not returning pop. We're just going to pop. Right? Yeah, because it's a straight on. So in this case, Q dot pop. So we're going to have to return it because it is an int. It's a required return. So we'll return that. And we'll also have to return the Q dot peak. And then we'll also have to return the Q dot is empty. Spell it right. Okay. All right. So now we need to go back and we need to build our constructor. So I'm going to take this. Q. So our constructor goes back, doesn't look right at all. I think, I don't even know if we need to initialize there. Yeah, let's try without, let's take this bits back to implement our cube. Which one? I don't think we need anything in there. What did I do? Oh. Braces, false, false. Okay, yeah, so we didn't need to put a constructor up here. So I don't remember doing that before. So basically all the meat of everything is happening in this push up here when we need to push something onto our queue. All right, so let's go queue. No, that's false. So push, push. Probably get some weird error because I'm not sure if I did a test right. Oh, man, now my test code's totally done, but I know it works, so I'm going to submit it. All right, so again, we're top percentile for quickness, although our memory usage was not great. We're in the lower half of our memory usage, but that comes into play because we're using two different stacks. There are ways you can do it with one stack, but we went with the easier method. Okay. So that's our implementing our queue using stacks. So what we're going to do is we're going to try to do it the reverse way, by implementing a stack using the queue. So we're trying to make a first in, last out using a first in, first out approach. So I'm going to do that. I'm going to come over here. I'm going to do now my stack. Take that information here. All right, so now we got queues. So now we're gonna have to go back and we're gonna have to use our linked list again. So we'll use linked list for our queues. So we're gonna implement two linked lists. One will be our temp and one will be our value where we need everything. We're not going to need anything in our data structure here, but we are going to start with our push. So much like where we did everything in our push on our last one, we're going to do a lot of stuff here in our push too. All right, so we'll start with if so we're going to start with if it's empty. So we're just going to use the method down below here for empty. So if it's empty, then what we're going to do is we're going to take our queue. So that'll be Q1. So we'll offer that to our stack. So we'll push the X to our stack. And then if not, then we're going to end up doing whiles. So while stack has, so in the queue, when we're doing the linked list, we don't have like a way to tell if it's empty or not. We do in stacks, but not here. So we're going to use size like we do in array where we use length. So if stack has size, in this case the queue, I think that's actually probably another if. So if it has size, then what we're going to do is we're going to take and push X to temp, so a temporary queue, and we'll make this gets complex because we're going to worry about the size of everything. So let's take, yeah, we're going to need size. So we'll size variable. We need this because we need to create a variable because if it's half number or something, then we're going to end up getting messed up when we try to pull the size. So we'll use while size is, it has size. Then we're going to go and we're going to take and push stack to temp. So just like we did before, I'm going to push all the contents of the stack and we'll push it in the temp queue. And once that's done, we'll decrement size as our way to get out of the while loop. So we'll go from whatever the size is of our queue down to 0, and we'll decrement every time we go through to count it that way. And then we're going to have another condition here, so we'll do an else if. So else if temp has size, so if everything's over in the temp, then we need to put it back over into the stack, right? So then we're going to take and we'll push X to stack instead of pushing to this temp. And then what we'll do is we'll do the same thing. We'll have to while our size, and then we'll we'll change this. So we're going to take from temp. No, I'm sorry. So we have to push temp back over to the stack. So that should settle our push. Our pop is going to be a little bit fancy too, because we're going to have to go through and we're going to have to figure out where everything is. So we'll do if stack has size, then we'll pop stack. And conversely, if everything's in the temp has size, we'll pop from the temp. So top, which is our peak, we're going to end up doing the same thing here. So we're going to end up, no, that's going to be returning to, so we're just going to take this and we're not going to pop, but we're going to peak. Oop, not back, peak. We get the peaks, and then our empties are going to be return if both are empty. So we'll return the empties if both are empty. All right, so let's implement our list. So we have linked lists. First one we're going to call, make sure that there's an integers on here. this one stack. Yeah, first one stack. It's new. List. There. And list. There. So temp stack or temp stack or temp queue, if you will. List. Integer. We're not going to worry about our data structure here, so we're going to go right into push. So start with an if statement. So if, and this is if both are empty, because we're using this method down here. So if both are empty, then what we're going to do is we're going to push onto the stack. All right, so we're going to stack. Now, for using a linked list, we have a slightly different set of commands, and then pop and push. So our push essentially is called offer. So to stick stuff onto a linked list, we use the method offer. So we're going to offer the variable X onto our linked list. So that'll be the head of our linked list, our first entity, because our lists are empty. So if they're not, this is just going to be an else. Put my semicolon there. If not, we're going to do an if statement. So if our condition here is our stack, and if it has size, so our just like length for array or length in the parentheses for the length of the string, size in the parentheses is the length of our stack. So if our stack has any length, or our queue, I should say. So our queue, if it has any size, so greater than 0, we are going to then push. So that's going to go down to here. So we're going to push onto the temp stack. So in this case, it's temp, and we're going to offer again, and it's going to go X. Right. So we're going to create our variable size. So this is just going to be an integer since it's just the size of our queue, and this is going to be our stack, because that's where where everything's supposed to be. Right. So offer, we went into the temp stack, first in, first out. So we're going to then go and we're going to do a while loop. So while size is greater than 0, so size is the variable we just built, then we are going to go in, we're going to push a temp offer, and we're going to then go stack and so we're going to pop. So offer is push, pop is going to be poll, like in election poll, the polling station. We're going to poll um, what's in the stack and push it into temp. Then what we're going to do after that, oh, semicolon, not a colon, is we're going to take size, decrement it, there are two minuses, finish it off. So else, if, in this case, if temp has size greater than 0, then we are going to mess around with temp and do the same thing we did here. So we're going to instead offer stack x, and then we will while. Now take that back. We can't while yet because we may not ever create size. So let's make sure we correct size. So non-stack, we're doing temp this time. So while size is greater than 0, just like we did before, we will go through and move everything to the other side. So we're going to stack, oh, stack, offer, temp, pull. We're going to then decrement size. And that's going to finish off our push. And so we're just going to, again, non-pop. We're just going to check our size. So we're going to if stack size. Then what we're going to do is we are going, well, sorry, size greater than 0, because then we know it has size. We are going to return back the pop of the stack. So that's going to be stack and pull because we're working with the queues. And so if not, or if temp has size, we're going to do the same thing. Return temp pop. So basically, we're just going to keep doing this for this next one. With the same construction, the same basic principle. Size, we have size greater than 0. And we're going to return. In this case, we're going to go from stack to peak, because peak is the same one. So that makes it easy to remember that one. And then if temp has size, so it might be a little confusing because you probably should have just named this like stack 1 and 2 or Q1 and 2, because when we're implementing the stack with the queues, we're not really always moving them back and forth as rigidly as we were when we were implementing the stack using queues, or the queues using stack, sorry, because there's a lot more flexibility with the queue. So that's why we're having to do two statements down here, because depending on which side all of the information's on and which queue, we need to be able to return that information. So and then empty, we're simply going to return. It's going to be stack is empty and temp is empty. And so this should now implement the stack using the queue. So let's go. I'm going to take this over. Paste this in. All right, so let's test ourselves out. Oop, 962. What did I do? Missing return statement. Oh, okay. We need to have another return statement just in case, apparently. So if there's nothing, we'll just return 0. Because nothing equals 0, right? And 65. I'm going to have to do the same thing. It's going to want to return for 0. Fingers crossed that that's all we have to worry about. All right, good. Okay. So we were accepted. My stack, we get the 2 pushes, push 1 and 2 on. We have the, we topped, which returned 2. We popped, return 2, and is empty, return false. So if we were to think we can do this safely this time. Pop another one here. We should return true or is empty. No. I'm not understanding these test cases. There we go. Okay. So we my stacked, which was nothing. We pushed 1 and 2 in, which returned null. And then we topped, which is basically the peaking. We peaked and we saw that 2 is the first in, or the top of the, and then we popped 2, or the bottom of the stack. Top is the bottom of the stack. And then we popped, or the top of the stack, sorry. Yeah, peak. So the top of the stack was 2. And then we popped 2, and then we popped 1, and then we checked if it was empty, and it was empty because we only had 2 elements on there. Okay. All right, Selena, I guess I already missed you. All right, so that's this one. I'm just going to click the submit. So we're very quick this time, and we have almost a perfect memory usage. Not quite. 0.55%. What's up with that, Robert? All right. So, Robert, since you're the last man standing, do you have any questions? I do not. Did you learn something today, maybe? All right. Were you contemplating what some of the other guys are contemplating? Are you going to stick on the basically on the um, IT side of things or security side of things? Or are you thinking about going and also doing a master's in the CS, like some of the other guys are? All right. Well, maybe I'll help you out a little bit. All right. I'm going to stop recording.